everyone. Today we will learn the principles and applications of time division multiplexing TDM. The content is divided into 5 parts. The principles of TDM, its characteristics and applications, a comparison and application of the E hierarchy and T hierarchy, a schematic diagram of the E hierarchy structure, and the frame structure of the PCM primary group. First, let's discuss the principles of TDM. Regarding multiplexing techniques, which one did we introduce in analog communication systems? That's frequency division multiplexing FDM. Remember, examples include FM radio stations, AM radio stations, multi-channel carrier telephone systems, and our television programs. We say which channel to watch, which also means different television stations occupy different frequency bands to transmit their signals. FDM can be used because when a physical channel's transmission capacity exceeds the requirement of a single signal, that channel can be shared by multiple signals. For example, telephone system trunks often carry thousands of signals in a single optical fiber. Multiplexing is the technology that addresses how to use one channel to transmit multiple signals simultaneously. Its purpose is to fully utilize the channel's frequency band or time resources, improving channel efficiency. What we introduced today is time division multiplexing. Earlier, we learned PCM technology for digitizing analog signals. TDM is intended for digital transmission systems, while analog transmission systems can only achieve FDM. Now let's learn how digital transmission achieves TDM. In the process of analog to digital conversion, first consider sampling a baseband signal. As long as the sampling pulse width is sufficiently narrow, there will be some time gaps between two sample values. Then consider sampling two baseband signals, M1 and M2, at the same time period. If the sampling instant of one signal falls within the sampling time gap of the other, the sample values of the two signals will not overlap in time. By extension, we can sample n signals within the same period. In the figure on the right, there is a sampling switch. One full rotation of the switch represents one sampling period. This is the principle of TDM. Next, let's analyze the information rate after TDM. Assuming the signal sampling frequency is Fs. The sampling time interval is t equals 1 divided by Fs. N signals all need to be sampled within the t period, which is also called the frame period. Since there are n signals, the time slot width occupied by each signal is only t divided by nfs. The sample sequences from each signal after sampling are combined to form a group sample sequence. Each sample is encoded into a code word consisting of n binary digits. After combining, there are a total of n times n binary bits. The combined information rate is n times fs. Characteristics of time division multiplexing. First, the basic conditions for TDM. 1. The signals from each channel must be organized into frames, forming an integrated whole. 2. A frame should be divided into several time slots, each time slot carrying one channel signal. 3. The frame structure must include frame synchronization code. When signals from different channels are not sampled by the same clock, minor differences in sampling rates, clocks of input signals must be tolerated. Now, the advantages of TDM. The first advantage is that it facilitates signal digitization and enables digital communication. The second advantage is that it is relatively easy to manufacture and debug, suitable for implementation with integrated circuits, resulting in lower production costs and a price advantage. Now, its application areas. It is mainly used in digital telephone communication systems, such as the wired telephones installed in our homes, and also, for example, the official telephone systems in our railway system. Other enterprise telephone systems are the same. Companies like CTE in our country started with stored program controls PC telephones. We just mentioned that data frames are composed of individual time slots. But what is the standard? How many time slots are appropriate to form one frame of data? This is established by standardization bodies. Only with unified standards can true global connectivity be achieved. It can be said that those who set the standards become top-tier enterprises in communications. Companies like Huawei and ZTE in our country are at the forefront in setting 5G standards. The International Telecommunication Union, ITU, has established two plesiochronous hierarchies for PCM TDM, the E hierarchy and the T hierarchy. The E hierarchy is based on 64 kbit phase second, A-law PCM voice signals, with a primary rate of 2.048 mbit phase second. It is used in mainland China, Europe, and as an international interconnection standard. The T hierarchy has a primary rate of 1.544 mbit phase second and is mainly used in places like the United States and Japan. Each hierarchy can have up to 5 levels of multiplexing according to application needs. For example, the E1 multiplexing rate is 2.048 MB phase second, and the T1 multiplexing rate is 1.544 MB phase second. The first level is multiplexing. Levels above can also be called multiplexing or higher order multiplexing. This diagram shows the E hierarchy structure. The first level of multiplexing is also called the primary group, the second level the secondary group, and so on. The frame structure for multiplexing above the secondary level will be covered in detail in the Railway Communication Transmission course. Here, we focus on the TDM frame structure of the primary group. In the primary group, each frame consists of 32 time slots, each accommodating 8 bits. TS0 is used for transmitting synchronization code, sent in the TS0 of even numbered frames. TS16 is used for signaling and can also be used for voice transmission. The other 30 TS are used for voice channels. Based on previous knowledge, the sampling frequency for each PCM voice channel is 8000 Hz, so the sampling period is 125 microseconds. This is also the frame time or frame period. What is the bit rate for 32-channel PCM? According to the earlier formula, it can be calculated as 2.048 MB phase second. In communication engineering, we commonly refer to this as a 2M line, which is also the smallest unit for multiplexing. In subsequent courses on railway official telephone systems and railway dispatching telephone systems, we will use this 2M line. Everyone must understand and grasp this knowledge point. Today, we introduce the principles of TDM, its characteristics and applications, a comparison of the E hierarchy and T hierarchy, a schematic of the E hierarchy structure, and the frame structure of the PCM primary group. Everyone, the times are constantly developing and progressing. The rapid speed of development in communication technology is evident. Whether one gets left behind in the tide of development depends on whether one possesses lifelong learning ability. Live and learn. Let's encourage each other with the saying. That concludes today's lesson. Thank you.